Alright, the activity we're going to do today is introducing the unit circle, and we want to define what the unit circle is. We're going to look at finding angles on the unit circle and also the coordinates of the point. So by the end of today, you will have a completely filled out unit circle. You have a handout that's blank, and as we go through different things, you can label what we put in, and then you'll be finding the rest of it in the activity to follow. Alright, so let's talk first about what the unit circle is. A unit circle, unit meaning one unit, is a circle whose radius is 1. And it's also, since we have angles in standard position that always have to be with a vertex at the origin, the center of our circle is at the origin of our coordinate plane as well. So since the radius is 1 unit long, here, we also can find 4 points on the circle, and these are the first 4 points that you need to know. We have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Right, now these are the easiest 4 points to find on the unit circle, and you'll see why those are useful later. Okay? Well, one thing I want to point out is notice how all of this relates to the Pythagorean theorem. A squared plus b squared equals c squared. For every point on the unit circle, the x-coordinate will give us one side of this little right triangle. The y-coordinate will give us this side of the right triangle. And then we have this angle theta, that's the angle in standard position. Okay? So let's talk first of all about the angles on the unit circle. I'm going to do everything in degrees, and the first part of your job after this is to find all of these angles in radians. And remember, leave your angles in radians in terms of pi as fractions that are reduced. Okay, and you'll see why once you get done. There should be some patterns that you can see if you do it all that way. Alright, so first of all, we're going to do all the angles in degrees, and you can fill these in on the handout as we go. Okay, if we look here at the first quadrant only, here's our positive x-axis. That's 0 degrees right there. Okay, and then we have a number of angles all the way around. Okay, in fact, there are 16 different angles that you need to know. Alright, this is 0, or you could also see it as 360 degrees, the coterminal angle. Okay, to find the rest of the angles, you'll notice these circles here to the right are divided up a little bit differently. Okay, for this one, basically what we're going to be doing is we're counting by 45-degree angles. So this angle right here is 45, which on this larger one, here's the 45-degree angle. Okay? This angle right there. Then, of course, we go up here to 90 degrees, which corresponds to the angle that makes this point 0, 1. Okay, there's 90 degrees. And then, of course, if we keep adding 45 degrees, we have 135 degrees, we have 180 degrees, we have 225 degrees, we have 270 degrees, we have 315 degrees, and finally 360 degrees. Okay? So that's the first way that our unit circle is divided up. We also divide it up a different way. So you can see this circle down here with the red angles. Again, we start at 0, and all these main angles are obviously the same. 0, 90, 180, 270, and of course 360. But now we're divvying these angles up and counting by 30s. So this is 30 degrees. It's the angle right here, 30 degrees. Okay? And then we have 60 degrees. Okay, here's our angle right here, 60 degrees. And then we keep going, 90, then 120, then 150, then 180, I'll move this here, 210, then 240, 270, 300, and 330 degrees. Okay? So, now you know all of the angles on the unit circle in degrees. Okay? And like I said, your first task is find all the angles in radians. Some of these will be really, really easy. Some of them will be a little bit more challenging. Okay? Now, the other thing that you need to do is you need to find the coordinates of all the points. Okay, you can see here we have the point 1, 0 and the point 0, 1. And we also saw negative 1, 0 and 0, negative 1. Okay, and you're going to work with your partner to find the coordinates of all the other points. Now, I'm going to get you started here, and this is going to be a good review of right triangle trig. Okay? And there's two ways you can do it. There is a pattern here for special right triangles. If you recognize your 30, 60, 90 right triangle, and so I had some answers here. You should be done with that anyways by now. We could use our 30, 60, 90 right triangle or our 45, 45, 90 right triangle, or instead we could use our right triangle trig, like we said before. Okay, and I want to do this because that will help us. Kind of refresh our memories on doing the right triangle trig. So where are these triangles coming from? Let's take a look here. Okay, you can see here the 30-degree angle is this angle right here. If I'm trying to find the coordinates of this point, x, y, the x coordinate will be this side of this right triangle, and the y coordinate will be this side of the right triangle. Okay? Now, remember on all of these problems that your hypotenuse will always be 1 because this is a unit circle. Okay? The radius is 1. So, I can use a little bit of right triangle trig with this triangle here, and I can say, well, the sine of 30 degrees equals y divided by 1. And you can use your calculator for this if you to find what the sine of 30 degrees is, and you'll find it equals 0.5. Obviously, y over 1 is just y, so y is 1/2. Okay, y is 1/2. If you used the cosine to find x, cosine of 30 degrees, remember cosine is adjacent over hypotenuse, so that would be x over 1. Let me raise this up a little. X over 1, which is of course just x. So if you punch into your calculator what the cosine of 30 is, you're going to get something like 0.866 and so on. Okay? Now, if we were to do this problem in terms of the Pythagorean theorem instead, you'll actually see where we get this root 3 over 2, because that 0.866 is root 3 over 2. 1 squared equals 1/2 squared plus the x-coordinate squared. This is 1/4, so we subtract 1/4 from both sides, and we have 3/4 equals x squared. And that means x is the square root of 3/4. Well, to square root a fraction, you can simply square root the numerator and square root the denominator. And that's how we get root 3 over 2. And when you are doing all of these, I would like you to do it in terms of that radical. Okay? Don't learn the decimals. Learn the root 3 over 2, because that's the exact value. 0.866 is rounded. Okay? Now, one thing that doesn't show up on your unit circle, but I would like you to recognize, is the tangent. Notice tangent is opposite over adjacent. Now that we know the two legs, we could say that the tangent of 30 is 1/2 over root 3 over 2. Okay? If you reduce that, it would be 1 over root 3, which is root 3 over 3. And that's how you should express the tangent if you were asked to find it. But notice what we actually found. And this is one of our trig identities that we'll use a lot more later, but we can see right now. Notice when I did opposite over adjacent, the opposite was the sign. The y-coordinate is the sign. And the x-coordinate, the adjacent side, is the cosine. Okay? I'm going to highlight this even more here in a moment, but your second task is going to be to find the coordinates of all of these points for the entire unit circle. So you're going to be finding, well, you already know 4 of them, with 1, 0, 0, 1, -1, 0, and 0, -1. But you need to find the other 12. Okay, and I just found one for you. It's the point 1/2. I'm sorry, not 1/2. Root 3 over 2, 1/2. Okay? So now you need to find the other 11. That's your second task. Find all of the points. Okay? Finally, I just want to point out what we just observed. The sine and cosine on the unit circle, the values are the coordinates of the points. And you can see here, sine of theta is the y-coordinate, cosine of theta is the x-coordinate, and then you can easily find tangent of theta by taking y over x. And I hope by this you can see why learning this unit circle is going to be so valuable. Because once we have this, we will actually have memorized the sine and cosine and can easily figure out the tangent of all of these angles. All of the angles that we saw back here. You'll be able to tell me what the sine of a 150-degree angle is, or the cosine of a 300-degree angle, or even the tangent of a 225-degree angle. You'll be able to know and recall those by the time we're done with all of this. So, go ahead and start. If you didn't pause and do the angles first, go ahead and do task 1, convert all these angles to radians, and then secondly, find all the coordinates of the points and leave them in terms of the radicals, okay? I'll tell you right now, for the 45-degree one, if you do it with your calculator, you're going to get 0.707, 0.707. But I don't want to see 0.707. I want you to give that in terms of the radicals. So go ahead and take your time and figure that out. Okay? Have fun.